Welcome to Introduction to Machine Learning for Time-Series Data. This course is focused on the intersection of machine learning and time-series data, and hence we expect you have taken introductory courses on machine learning and time-series analysis here on DataCamp. This course focuses on machine learning in the context of time-series data. Put simply, a time series means data that changes over time. This can take many different forms, such as atmospheric CO2 over time, the waveform of my voice as I am speaking, the fluctuation of a stock's value over the year, or demographic information about a city. Time series data consists of at least two things. 1. An array of numbers that represents the data itself. 2. Another array that contains a timestamp for each data point. The timestamps can include a wide range of time data, from months of the year to nanoseconds. Here we import time series data into a pandas DataFrame. Note that each data point has a corresponding time point, in this case, a date, though multiple data points may have the same time point. Here is the code to plot this time series data with matplotlib and pandas. We first create a figure and axis, then read in the data with pandas and use the plot method to plot the data on the axis. The amount of time that passes between timestamps defines the period of the time series. In this case, it is about 1 day. This often helps us infer what kind of time series we're dealing with. Machine learning has taken the world of data science by storm. In the last few decades, advances in computing power, algorithms, and community practices have made it possible to use computers to ask questions that were never thought possible. Machine learning is about finding patterns in data, often patterns that are not immediately obvious to the human eye. This is often because the data is either too large or too complex to be processed by a human. Another crucial part of machine learning is that we can build a model of the world that formalizes our knowledge of the problem at hand. We can use this model to make predictions. Combined with automation, this can be a critical component of an organization's decision-making. Why should we treat time series any differently from another dataset? Well, machine learning is all about finding patterns in data. Time series data always change over time, which turns out to be a useful pattern to utilize. For example, here is a raw waveform of someone speaking, and here is a collection of time series features that were extracted from it. As you can see, using time series specific features lets us see a much richer representation of the raw data. This course will focus on a simple machine learning pipeline in the context of time series data. This boils down to the following main steps. Feature extraction. What kinds of special features leverage a signal that changes over time? Model fitting. What kinds of models are suitable for asking questions with time series data? Validation. How can we validate a model that uses time series data? What considerations must we make because it changes in time? Let's start by plotting